Hi everyone. Have you ever seen what I'm holding in my hand? This is a FrenchKit card game in which you can find really pretty cards representing a great third-party framework from GitHub. And you can also have information such as the number of stars, the number of commits, and so on. I hope you like these cards. Me, not so much. Not so much since I discovered a major flaw in its design. These cards are outdated. They are outdated since these cards were printed because the number of stars may have changed and any other information that you can see anymore on your card. As a developer, I don't like outdated stuff, but I also like solving problems, and that's what I did with a demo. So. Okay, right. So what I wanted to achieve when building this app is analyzing my environment, then maybe detect the card. And when I detect the card, if demo gods are with us, or maybe not, or yes, you can display a newly updated card in a 3D way. So you have all of the information from GitHub that are now updated. But that seems pretty easy, right? But in fact, there is a lot of things that are happening behind the scene, as you can see. You can see these red rectangle, yellow points, and so on. So first of all, I'm going to talk about the tools I used to achieve this app. First one is Vision. Vision is an image recognition framework that was introduced during WWDC this year. There is also ARKit, the hype augmented reality framework also introduced this year. And I used SceneKit as a 3D renderer for ARKit. So if we go step by step, what happened during the demo? First thing I need to do is detecting the surface in which the card is placed. And this is ARKit job. Then, what you need to do is detecting the card. And the card is a rectangle. That's a good news, because Vision can help us to do this. So I have this rectangle with 2D coordinates about it. But I still need to have real-world information about it, like its size. And this time, size matters, because if the size of the detected rectangle matches the size of the card, well, maybe it's a FrenchKit card. But we need the last piece of information. This is a reason why there is a QR code on this card. Vision can help us to detect it and to decode it. And with all this information, I can draw my 3D card with updated information. So let's talk about steps that involve Vision. Vision is, according to Apple, a high-level on-device solutions to computer vision problems through one simple API. But I prefer my definition, which is much more simpler. It's a framework that detects stuff on images. So what you need to deal with Vision are these three nations. You add stuff to a complicated machinery, and you get observations as a result. So if I want to detect a rectangle, I declare a detect rectangle request, which is the ask. I use the request handler as a machinery, and then I get rectangle observations as a result. And the three of them give us the asks, the machinery, and the results. So let's go deeper into the code. I want to detect a rectangle, so I do detect rectangle requests with a completion handler. I declare a handler with an image as input. That can be a CI image, CG image, CV pixel buffer. That can be data, URL, and so on. Then I perform one or more requests, one in my example, and when the request has performed and is finished, then you enter the complaint handler, you get observations, which are part of the request, and on these observations, you get some interesting properties, like in this example, the top left corner coordinates of the rectangle. And if you know how to do a rectangle request, then you know how to do barcode detection. This is pretty much the same, except that the observations you get are different, of course. And in this example, I just get the content of the QR code. So Vision gave us pretty much all we needed to complete two steps. The first one is getting information about the cards with the QR code. Also, we have the rectangle that surrounds the cards. But this is a rectangle with 2D coordinates that are relatives to your phone screen. What we want are informations about real-world position of this card. And for this, we are going to ask ARKit. And we'll use SceneKit to do the 3D stuff. So before going deeper into ARKit, you need to have some notions about SceneKit. I won't go really deep with SceneKit because it's a huge framework and a complex one. There is only one notion, in fact, that you need to master, is the node, or SCN node. A node is just a structure that represents a position and an orientation into space. You can attach a geometry to a node, which can be a plane, a sphere, or even text. In fact, that can be pretty much everything you want. These geometries hold informations like texture, image, or color. And with all this information and with your node, you attach your node to a parent node and to another parent node and maybe brother nodes. And you build all your node hierarchy that you are going to attach to a special node, which is the root node that ARKit gave us. So if you understood what a node is, well, you understood pretty much everything about the combination with SceneKit and ARKit. So let's go back to ARKit. What ARKit helps us to do is understand the scene you are filming. By example, it can do plane detection. But more generally, it can do pretty much, it can detect pretty much any surface you want. So to start playing with ARKit, you just drag and drop an RR-SCN view, ARKit SceneKit view, and then you need to do a bit of setup. You need to check if your device is compatible with wall tracking. Wall tracking allows you to do plane detection and use 6 degrees of freedom on your 3D object, its position and its orientation. If you can't do wall tracking, then you can still use ARKit, but with limitations. And I have a device that supports wall tracking, so it's great. Then you ask to do plane detection, just like that. You set the scene view delegate, or if you don't, you just have a camera. And then you run a session with a configuration. And when you do that, you have access to plane detection. When you are filming and ARKit start detecting a plane surface, it will call the delegate method and delivers two main things: a node to attach 3D content and an anchor. An anchor is like a position and a surface which is tied to real world. That means when you film elsewhere from your anchor, it will remain here. And when you go back, you recover your anchor. So an anchor is a way to attach a position, and you just put your 3D content on your anchor to recover it at the same position every time. So what I did right here is displaying a blue grill on my table. And for this, I just get information from the anchor, which are the width and the height, mostly. And then I just build a node from it and attach it to the node that ARKit provides me. Plane detection is useful in my case to have an anchor to place my virtual cards. But when I detect a plane, I'm pretty sure I have enough feature points. Feature points are the yellow points you can see on the image. And they represent information about a continuous surface that you detected in the real world. And if you have enough filter points, you can perform IT test. IT test is a process of taking a 2D position onto your screen and map it to a real-world position. Oh, sorry. IT test is pretty straightforward. You just take your scene view and you call IT test on it. You give it a 2D position and a type of IT test, and then you get results. What I did on my sample app is IT testing every corner of the rectangle I detected with vision. And as I have every information about the rectangle, I can deduce the size of the rectangle, and then I can try to see if the size matches with the FrenchKit card size. Sorry. And if it's the case, and you couple information with what you detected with vision, the QR code, then you can draw your content. And that's it. Thank you for your attention. If you want to talk about ARKit, feel free to contact me on Twitter if you want.
Thank you. Congratulations for the demo.
Thank you.
Just one word before we talk a bit more about your talk. Right after the Q&A sessions, we would like all the speakers to jump on stage to make a nice photo. So be prepared, guys, so that we don't lose too much time to come on stage. So how much time did you spend to learn that and then to bring this demo together, like all the code?
Quick answer is too much time. As a non-3D developer, I spent really much, the most of my time mastering SceneKit, which is really complex with a lot of confusing things. For example, when you use text, they are not centered. Everything is scaled with ARKit, so if your font size is 16 with a text, you have a huge text. So you have to do a lot of geometry to position correctly your content. That was the hardest part.
And what about the interaction between ARKit and SceneKit? Does it play well together? Is it easy to set up?
Yes, ARKit has been thought to play with SceneKit for 3D content and SwipeTick for 2D content. So it's an API. It's pretty invisible that you use SceneKit. You can use a custom renderer if you want. That will be really harder, using Metal, for instance. But yes.
For Metal, it would make sense. I thought Metal would be SceneKit would use Metal to accelerate the rendering, maybe?
Yeah, you can use Metal just as a renderer, but you have to do everything by hand.
Oh, okay. That's maybe a little work.
Maybe ARKit for a simple presentation.
Next demo, yeah.
Yes, next demo.
Yeah, just one point to make things really clear is you don't use Core ML, right?
No, I use Vision.
Yeah, and I wanted also to emphasize that on the demonstration by David Bonnet, David is only using Core ML. He's not using either. I don't think even Vision, but it doesn't use ARKit. So it's really two techniques, two stuff really separated, right?
Yes, I could have used Core ML to detect directly the cards with the correct model.
Yeah.
But Vision...
Without the QR code, for example?
Without the QR codes, yes. But that was pretty much easier to use Vision because it gives us for free, nearly for free, every information you need to do the detection.
How long did it take to actually get all the information to build this project? So I guess there was time of actually creating, developing this project, but I guess there is a preparatory work to find all the information before putting them together. Was it hard, or actually is it accessible?
Well, Vision and ARKit are really accessible. As you could see, the API is really simple. and you just watch WWDC videos, and you know pretty much everything you need to know about it. Using Vision with ARKit was not straightforward, because you need to find a place to request new content, to detect rectangle, barcodes, etc. And you need to care about our performance, because Vision is pretty heavy stuff. So if you request too much, basically your iPhone will melt. So I used a bunch of tricks to not to request too much, to request one thing at a time, rectangle and then barcode, because if you do both on a CV pixel buffer, what ARKit provides you as an image, then you get this warning log on your Xcode and saying, okay, I don't understand anything anymore, there are performance issue, and then you can do anything with ARKit, everything is broken.
Yeah. And with which device? Is it really fluid? Can you do that on?
But this is fluid with my 6S Plus.
6S.
I think with the X, that would be awesome. But I didn't have the chance to test it yet.
Well tried.
Still with
So FrenchKit is not offering you an iPhone X, I'm sorry.
Yeah, thank you.
It's not offering you.
Or maybe Xavier, no?
Can I have one?
So let's move to the next subject. No, I forgot the question actually, but it's all right. So actually, as you said, if there are performance issues, I mean, if there are blocking things in your run, you can't actually debug anymore. Is that what you're saying?
It's not that you can debug anymore. It's just ARKit. You saw the yellow points, for instance. That you just go everywhere. Your 3D model goes now going to be broken.
Okay.
You just need to kill your app and restart.
All right. All right.
But debugging is not that hard. And especially with SceneKit, when you capture your screen, you can have a SceneKit scene with a 3D content that you can move, you can orientate, and that's a really good tool to debug this kind of project.
All right.
Nice. Okay.
So that's
Thank
all.
you very much
Thank you very
for this
much.
demo
Thank
and
you both
this
of you.
explanation.
Well done.